fragmentation. From previous class, we have looked at what is an index, and we're able to come up to say that an index helps us to retrieve data faster and efficiently. We also did establish that any table without an index or without a clustered index is referred to as a heap table. Now, having established the fact that there are two
we're able to come
basic
up to say
indexes that we're looking at in this helps us to
class,
retrieve
which
data,
is a
clustered index and a non-clustered index. We also did establish that when you create a clustered index, it will sort your data for you in an alphabetical order, reordering your data for you in an alphabetical order based on the key value. And that is why we cannot have more than one clustered index on a table. We did mention that with a non-clustered index, it is like a pointer at the back of a book pointing you to the actual data itself. In other words, a non-clustered index is a pointer to the actual index on the table. So therefore, you can have more than one non-clustered index on a table. And remember, when you're creating non-clustered index, because of that additional space, it has more, the size is bigger than a clustered index. Now, today we are going to be looking at index fragmentation. What is index fragmentation? Every day we do different operations against our database. We do what we call we insert data into our database, we update data, we delete. I mean, we perform all these operations every day. Don't forget that anytime you are querying a table with an index, when you search for an information, it has to go to that index and sort the data for you based on the key values. If you also delete any record from that table, it is going to, after deleting it, let's assume that whatever you deleted started with a B. The moment you remove B there, it's going to rearrange the table and put the next alphabet that was close to what you deleted on the table, thereby causing some space, some reordering of data inside. When you do this over the time, the data becomes scattered about in your indexes. You cannot see it physically, but inside it, that is what is going on. And so you now realize that when it is in that state, when you start querying your table, when you start querying your database, something that used to take you 2 seconds to give you your information will now be taking you a longer time because the index is fragmented. It's not like before. It has sag, what they call sag. They have overused the index. It's no longer holding its value. It's no longer strong. It is now weak. So your SQL Server will not be able to retrieve your data faster because the index has been fragmented. Okay? So whenever index fragmentation occurs, there are two things we need to do. We need to either reorganize that index or we rebuild the index, depending on whichever fragmentation that we have. Whenever we have an insert, an update, or delete operations occurring against our underlying data, SQL Server would automatically maintain the indexes. This operation can cause what we call the index fragmentation, and this can ultimately lead to performance issues. Okay? In a theoretical term, you can say that fragmentation exists whenever the indexes, fragmentation exists when index pages have pages in which they are logical ordering. When you say logical ordering, how do you arrange it logically? Based on that key value. If it no longer matches the physical structure, the physical ordering on the data file itself, because of constant insert, update, and delete operations, fragmentation has occurred. At that point, we need to rebuild or reorganize an index. When you say rebuild an index, what does that mean? When you are rebuilding an index, that means SQL Server will drop that index and recreate it for you. Think about it. That is intensive. So before you ever rebuild your index, please consider the size of that index. If it is a very big table, say a table with 1 billion record, if an index is on that table and you want to go and rebuild that kind of index, what do you think will happen? It will take a longer time to rebuild. Why? Because you are rebuilding an index in a very big table. So before you rebuild an index, you must consider it. That is why we have to be proactive instead of reactive. How do I mean? Please write this down in case you are listening to this video, we have a job, and the name of that job is called Index Optimize. The job is set up proactively to manage our index fragmentation. And the law simply states that when my index fragmentation is below 30%, reorganize the index. If it is above 30%, rebuild the index for me. In other words, before your fragmentation wants to cross your 30% yardstick, if you have a maintenance solution, it will avoid you from rebuilding. But if you don't have that in place and it passes 30%, maybe in a day, depending on the activity on that table, if we have a lot on a particular table in a day, fragmentation can jump more than 30%. At that point, you have no option than to rebuild. That is why in an environment, in an enterprise environment, we set this maintenance job to occur in the weekend. Why weekend? Because this table, let's assume the table is very big. In the weekend, our users will not be using the application as much as they use it from Monday to Friday. So we can set up a job called Index Optimize to start running on Friday night. At most, it will take 24 hours, but it will rebuild your index for you. So when users come back on Monday, boom, everything is working very fast. Data retrieval is very fast. Okay? So, and now think about it. Because you are rebuilding and recreating an index to remove fragmentation, it will reclaim your disk space for you. How does it do that? It compacts and reorders the index rows in the pages. However, when you are reorganizing your index, it does what we call it defragmentize, or it defragments the leaf level. Now write this down again. I did not talk to you about this. Index have a structure called B tree. When you say B for Bravo, and tree, like you're climbing a tree. Let me put it down here. Index have a B tree structure. So how does it work? The first one is called the root level of the index. We have the intermediate, and we have the third one, which is the leaf level, or the leaf. This is where all your data resides here on this level. So when you are rebuilding an index, if you are rebuilding an index, it will rebuild everything from the root level, the intermediate level, and the leaf level. So it is a very intensive structure. Task to do. But when you are reorganizing an index, it does not touch the root level, it does not touch the intermediate. It only reorganizes where your data resides. So this one is not intensive, like a rebuild. That is what that statement is saying. Okay? So how do we determine? Someone asked us during our discussion that how do you determine the fragmentation of an index? There's a system function that is called sys.dm underscore index underscore physical stats. This is a dynamic management view, or we call them DMV. It allows you to detect your fragmentation. That's the answer. That's one. Secondly, you can go to that. If you can locate the index, what do I tell you guys? If you can locate it in SQL Server, right-click it and you will see the option there. So if you go to any index, you can locate where the index is. Remember that your index resides inside a table and a table resides inside a database. So if they ever tell you go and check the fragmentation, the question you want to ask is what database is this index on and what table? When they give you those two information, you go there, open all the indexes, and you right-click each of them and you start checking their fragmentation level. Now, if the average fragmentation in percentage value that you see when you run your dynamic management view there's a script I'm going to show you that has this function. It will show you your fragmentation. You can either use that to check it, or you can check it using the GUI, the graphical user interface. Whenever you see that your fragmentation is above 5% but below 30%, all you have to do is right-click that index, reorganize it. Boom, it will reorganize it, arrange the data on the leaf level for you, and changes it back to 0. If you rebuild it, make sure that your fragmentation is above 30%. In conclusion of this theory regarding index fragmentation, you have to remember that when you are rebuilding an index, you can either rebuild an index online or you can do it offline, depending on whichever option that you choose, depending on how big that table is, where the index resides. But when you are reorganizing an index, it is always executed online because it's on the leaf node where the data resides. You cannot reorganize an index offline. So now let us go into SQL Server and let us just take a look and see how some of this index fragmentation can occur. So what we are going to be doing in SQL Server is that we're going to create a database. We're going to insert some data into the table, then create another. We're going to actually create two tables, put some data inside. One of the table will be a heap table. Another one will be a table with an index. And then we'll see how fragmentation can occur by putting in data, removing data, deleting something, shrinking the database, which I strongly do not recommend you do in your live environment. But we're going to do a lot of DML operations so you can see how the index will be stressed, okay? And then you'll be able to see how fragmentation occurs. Okay, so as you can see, we are now on our SQL Server. I'm going to connect here. I've connected. This script I will share to you. Let's just, before we run this, let us see what this script is going to be doing. This script is going to use master. It will create a database called shrink database. Let's just take it one step at a time. So you first of all create that one. Good, we are done. Refresh here. You see that you have created your database. But this is just an empty database. There is no table. So what is the next thing that we're going to do? We're going to use this database because our table has to be under it. We now use the database. We say, go, create this table for me. Give it two columns. One of the columns should be identity, and the other column should have a default value called front. Good. So I'm going to run it together. Execute. Good, I've executed. If you refresh this right now, you're going to see that there is a table called initial, but this table is empty. If you right-click it and do select up, it's empty. Column 1, column 2, there is nothing inside. So you want to say, use that table, now insert data for me, do it 1,500 times and insert the font values, the default value that I gave to that table, which is front. So put this front 1,500 times for me. Execute. Good. So it has done that. It has inserted records for me. Okay. Let me view this now and see. Execute this again. Good. It has done it how many times? Oh, it did it just 1,000. Okay, yeah, I said 1,000. 1,000. That's why it gave me 1,000. Good. Or you can use your script and say select star from initial. You can see that I'm running it line by line. If you select it now, you see 1,500 here. So if you go down to my last record, it has inserted the record 1,500 times from me. That's exactly what I'm saying. Now, guys, the reason I told you to do the 30 days challenge is because I know we're going to be running lots of scripts so that you can understand how to use script. If you have been doing the challenge, you would understand why I'm running script the way I'm doing. Okay. By the way, how do you put numbers to your SQL Server? Let me show you, because if you're running yours, you may not have a number. Let me just take a little digression and show you how to do it. You come over to tools, look at my, and you see where tools is? Click on tools, then you come to options, click on options. You go to what they call text editor. You open the text editor. It will be closed like this. You open the text editor. When you open your text editor, all languages will be closed like this. You open all languages. When you open this all languages, you would see it there, right there. You click on general. When you click on general, it will show you, you can select word wrap and line numbers. That's how I got these line numbers. So that whenever you're watching the video, when you paste the script the way I pasted the script, let me paste the script from line 1. So you can see that, okay, where did he use to check his right? When you see me, I'm on line 22. You to go to your line 22 and do what I did. Okay? So based on how I arrange this thing, but it just helps you monitor what you're doing. So now we have inserted a data. Now, this is a heap table. Why? Because there's no index, right? So we cannot see any fragmentation here, because you right click it, you only tell you to rebuild all or reorganize all. Do you see that? But right now we cannot reorganize all. What are we reorganizing? There's nothing there. So now we are going to create a second table. No, before then, let us check the size of the database. How do we check size of database? We use sp_help db and we help that db. You guys know this query already. Execute. So mine is saying, do you know why mine is showing 144? Because when I designed this table, when I designed my system, if you look at the size of this database, let's go to the model database. We set that up already. Let me see the size of the model database files. 88, okay, 88, 88. So this database, what is this size? Properties, files. You see that this one arranged itself. We gave it 72 instead of 88. You see, but anyways, let us leave it that way. Let me just put the size of whatever I am seeing on my own. I'll put it there, 144.mb. Please keep following me. That's the size of the database now. Okay, good. So we are going to create a second table. We put the same default value, call it after. You create a clustered index this time, and then you insert data into it. And when you insert data, default value 1,500 times. So I'm going to run mine to line 44. So I'll start to run from line 30 to 44. What will it do? It will create a second table for me. This one was initial. It will create another table, call it after. 2 columns, the same thing, column, then insert data into it and show us the result. Okay, execute. So it is creating a clustered index. It will take more time than the former one. Good. It's done. It has inserted data 1,500 times. If you come now and refresh this database, we should see 2 tables now. One is initial, one is second. So if you open this second, go to indexes now, you would see it. So we now have one index called COL, because that's what we call the index here. Create an index, :1 on this table. Okay. To answer the question that someone asked during our discussion, if you want to see the fragmentation level, right click this now. You see here, come to properties. We just only insert one data. We have not gone too far. You see fragmentation here. When you click on fragmentation. So the total fragmentation is 33%. Is this table highly fragmented? Is it highly fragmented? It just has 0.33%. Huh? Remember what we said. It's not fragmented at all, because we said above 5%. Right
it's
now,
less than 30.
I'm on 0.33%. Do we have to do anything? That's
At
what
all.
it's showing. My fragmentation is showing me 0.33%. Because why? We just inserted one data in. We just only did one insertion now. There's nothing going on that table. No so much, whatever. But let us check the size of this table. Okay. Yep. So I'm done with this. Let us see. We have selected. Let us check the size. Let us see the size. Because you know why it is like this? Because I sized my database correctly. So nothing happened. So now, guys, look at this. Look at this. Please think about it. I want to cause fragmentation. Now, when you insert data, because you see one of the good reasons, guys, look at the value of what I was teaching you since. Please pay attention at this point. When you get to this point of the video, please pay attention. When you size your database correctly, when you know the amount of data coming in and you size it correctly, please note, it will also prevent fragmentation to occur, because if the database is big enough, if the data that you put, the table can take, the database can take it, there will be no fragmentation, because the database is still in size to take everything that you are bringing in. So look at now. This database has not expanded in our own case, because it is big in size. So what I'm going to do now, I'm going to drop those two, I'm going to create it again. Okay, so that you can appreciate it. I'll create that database and then I'll give it a different small size so that you can appreciate. So if you're watching the video, you get to this point, please don't give up. First thing you need to do is that Control A, Control C, copy your script. When you copy your script, close that session. Then you can go and drop that database. We'll do it again, but this time around, I'll do it differently. Close the existing connection. After you drop that database, you want to start again, hit on new query, then Control V, paste that thing that you copied. Let us go first of all. I want to do a back. Okay, it's trying to reconnect to this new session because I disconnected. So it's connected back now. So let's go again from the top. Let's create this database. After we create this database, I want to see the size of the database. Help DB, shrink DB. If the size is big, I'm going to size it poorly so that, because what we're trying to see, we want to see fragmentation. Okay, so let me do this, create this. So before I even insert data in, let me see the size, line 10. You see it is now 16. Okay, good, this is 16. Good, this is what I want to see. Okay, 16. That's the initial size. Okay, good. So because we set up auto growth, let me see something. Refresh this database. I want to cause something that will not be too good. Just stay there with me. Go to files. See my auto growth. This is the reason. Okay. So let me do something that is bad. Let me leave it in percent, which is not a good thing to do. Which is not a good thing to do. This is a badly designed. You see what I did? Because of those auto growth, when you insert data, it expands automatically for you. But now I want to put it in percentage, which is a bad way to size your database. Good. So now let me create this table initially. Okay, and insert data into it, and then we see what we have done. Execute. So it's going to show me my result. Is to create that table and show me my result. Good. It has done it 1,500. If we open this now, we would see under the table, we are going to see that. Good. This is a heap table because there's no index inside. If you open the index, it's not there. It's a heap table. So now let us see the size. Now that we have put data in that poorly sized database. You see this one? Good. This is what I want to see. Because you see the benefit of auto growth. Because I changed the auto growth setting. See, initially, when you did not change the auto growth, in as much as you have space in your disk file, it will expand automatically. But now I went to set it poorly. You can see that the auto growth did not look at the data. And even we left it the way it was. The moment it reached that size, it has 64 megabytes to it already. So good. I love this one like this. This one will be able to help us appreciate it more. The initial size right now is what? Is 25. Please do everything that I'm doing. This is my own initial size, 25 MB. Good. This is good. This is close to what I want to see. Let us create a second table and put data inside and then create an index. And then we check the size again. Insert data into the table. Then we select it and view it. Execute. So I now run from line 31 to line 45. Good. I've refreshed my table now. You'll see that I have two tables. This one is not a heap table because it has an index. Look at it. There's an index. So let us check the size after we have created an index and inserted another data. You see that? Good. This is good now. It has increased in size. It's now 36. Initially, it was what, guy? It was 24. The size is now what? 36 in my own case. You see it? The database has expanded due to an insert of data. The database is now expanded to 36, to 38 in my own case. Then now let us check the fragmentation level. You see that function that we saw on our notes? This is the function here. So you can either use this one or the GUI. So now I want to ask you guys one intelligent question. From these two tables, where do we check fragmentation? Which one will have fragmentation on these two tables? Initial or second?
The DBO dot second.
Second. Why? Because this one is a heap table. This one is not a heap table. So let us check fragmentation. How do we check fragmentation, guys? You go to the index. If you can locate it, right click it. Where do we go? Properties. When you go to properties, I'll use that one to show you, and I'll use, then you go to fragmentation. Right now, the fragmentation is at 0.33%. We agreed? Good. So let me use this script now to run my index fragmentation. Execute. So this is the same thing, 0.33%. So now notice that the fragmentation of the clustered in, notice that the fragmentation of the clustered index is almost zero before we shrink it. That's why we call the something shrink database, because we want to shrink it. When you shrink it, you are trying to make the size smaller. Remember that if the index is inside, think about it as index is inside your table. You are now pressing that table. By the time you finish pressing it, it has to adjust itself to accommodate that size you are giving to it. So when you press it down, you have destroyed the index inside. Okay? Watch this. Remember that what causes fragmentation? Fragmentation occurs when we delete data. When we do anything now from it, now watch that. We will now drop the initial table we created. After we drop it, we will shrink the database to reclaim space, okay, in front of the data. Then see what happens to fragmentation when we do this DML operation. We want to delete, we want to perform some operations that will cause fragmentation on that index. Watch it now. So now I want to drop this table. What's the command? You can right click it and delete, or you just run this 2-line. I prefer to run that 2-line because it's easier. Good. I have deleted that record. If you refresh now, we only have one table. We only have one table left. Then now that we have one table left, the size, remember that the size has increased to 30 something, 38. Want to shrink it now, want to shrink that database. I don't advise you to shrink database in your office, but because we want to press on this index that is inside here, this index is already inside here. We want to shrink this database, we want to make the size smaller. Because when we make it smaller, remember that this is inside it, it will also shrink it. So that will affect this index inside there. We'll now check it. Okay. What is the command? Okay. Now that we have dropped the data, we have deleted a data inside, right? Definitely the size would have reduced back. Let's see. Well, this one, our own size did not reduce after we deleted data. It still remained at 38. Yes, that is it. The size remained initial. Why? Because, guys, watch, there's a theory here. Because we dropped that database, it did not shrink that database. When we dropped one table, it did not shrink the database in any size. It left it at the size that it has after we inserted data. Look at it, 38.63. Look at it. After we inserted data, the database expanded to 38. In spite of the fact that we deleted something, we dropped a table, it did not reduce the database size. So now I want to reshrink it to claim that size that we just deleted. Okay? So now we are going to shrink the database using this command called dbcc shrink database and the name of the database. Let us shrink it. Execute. You see now we have shrunk it. We have shrunk this database. Now you see the pages. These are the pages. It has been shrunk. Okay, let us go and see. Now that we have shrunk it, let us check the size again. You see that the size has reduced. Good. Our own has reduced from 38 to what? 22nd. You see that when you shrink it, you've done something to that database now. The size has reduced from 38 to 22. But notice what happens now to fragmentation. We just shrink something, right? Let us go again and look at the fragmentation. Refresh this table. You will see what has happened now to the index just because you did some operations on it. Properties. Check your fragmentation. What do you see, guys?
It has increased
To what?
99 points.
So at this point, what do we do? Are we going to rebuild this index or we are going to reorganize it?
Rebuild.
Gonna
Thank
rebuild.
you. Because the fragmentation is above what? 30%.
30%.
30.
Excellent. So now, because this is our lab environment, we are trying to create something to show how index can be fragmentized. But in your work environment, so many people, so many applications, different things are running on that database. So you may not be the one to do all this activity. Your own job will just be, let me check fragmentation level. Because you don't know who and who has done anything on the database. So part of what we do to maintain the database is that we have to go and check, has it been fragmented? What has happened? So now that we have checked using the GUI, look at what it says. Notice what happened. When checking the index fragmentation, we notice that the fragmentation has to almost 100%. This is because we shuffled all the data pages when we're shrinking it. Remember, if your size was 5 MB, you now went to press it down to 2 MB, and you have index inside there to have scattered your index. So that's what, if you use this script now to check it too, it will show you the same result. Look at your fragmentation is almost 99.6%, which is this here. Okay? While the database has shrunk and we have reclaimed space, we must now fix this one. So we have shrunk the database, we have gotten more space, but then we have to now fix fragmentation. Do we rebuild or reorganize this index? You guys got the answer. We have to rebuild it. Look at it. That brings us back to our term. If average fragmentation is greater than 30, what do? We rebuild. That's the law. So now that we know, so how do we rebuild index? It's easy. The name of the index is this column. You alter index column on that table called second. You rebuild it, or you simply do this one. What do? You right click and say rebuild. Do you see it here? So you can use this GUI. When you do this GUI, it's the same thing. If you script out this one, clipboard. I just scripted it out, right? Good, I scripted it out. Let me paste it here. You see how that long English is speaking? You see it? Use, go, alter index. You see it? Now, see something. Remember I told you guys that when you're rebuilding an index, you can rebuild an index both online and what? Offline. Do you see it? So this one now we are rebuilding it offline. Can you see it? Are you guys with me? It's part of
the yeah, go on.
Yeah.
Look at it here. We said rebuilding an index can be done offline.
Online or offline.
When you script it out, it will show you more things. So now what is it telling you? But now let's see if we want to rebuild. Let's assume we wanted to rebuild this index. Rebuild, script rebuild out. You see that rebuild will not have any offline listing. Look at rebuild. Let us put rebuild script. Rebuild as offline here. Let me see. Oh, goodness. What am I doing? I'm doing the same thing twice. Let us reorganize, beg your pardon. Reorganize index. Script it. Let's see if it will show us an online listing for reorganize. You see it? You cannot reorganize. When you're reorganizing an index, you cannot do it offline. It has to be online. Can you see the difference? Can you guys see the difference?
Yes.
Okay,
yes.
That's that theory there. But in this case, what are we doing? We are rebuilding the index. So you can run your script to rebuild it. This is it here that you scripted out. Or you use or you use it not, or you use this. This is the one that we scripted out. We scripted this one out. We scripted out this one. You can either run this one or you run the other one. Let me run this one, or this one does the same thing for you. Or which one do you guys want us to do? GUI, this or this one? Which one do you guys want us to run to rebuild our index?
The GUI.
Let's do script.
GUI is better.
Okay, let's do GUI. Right click and you come to rebuild. You just click OK. Easy, done. Let's check the fragmentation now that we have rebuilt. How do we check fragmentation? Tell me using the GUI. Who can tell me? How do we rebuild? How do we check the fragmentation on this index?
Right click the index. Properties.
Properties.
Fragmentation.
Then fragmentation.
What's now the fragmentation?
0.
0.
Excellent. Because he did what? He rebuilt it. So this was faster because you can also use the script to check it. It's 0. This was faster because we used what? We used, the table is not big. You can just check the size to see, because when you rebuild an index, definitely the size has grown. Because rebuilding an index will do what? It means logging of the index.
Create more disk space.
Exactly. Look at it here. Where is that thing? Who can see it? Where is that thing? Where's that theory? The theory was somewhere. Yeah. Where is it?
Oh.
So we rebuild an index. So we have reclaimed our disk space. Okay, that was what happened when we compacted those data and reordered that thing. But when you are rebuilding an index, you must consider space too. Space will increase because you have to log that index. It has to increase it, so the size now increased to 42. So please, if you do not do this demo, you are not doing me. I will need you guys to practice. I'll send you the script. As soon as we end this class, you're going to get the script. I want us to practice this index before our next meeting. So this is where we have to draw the curtain on index fragmentation.